Hello, am I audible to you? Okay, so let's get started with another session. In this session, I will discuss how to calculate complexity of recursive relation. Okay, how to calculate complexity of recursive relations. So now you can see this is selection sort. This is selection sort algorithm. So what I was discussing in the last day regarding selection sort algorithm. So here what you can do that you need to create separate functions. So one function would be finding the smallest element. Okay, okay, screen not visible, no? Okay. Yes, actually, I was discussing this topic in the last day. So, in this case, what you need to find out, you need to find out the minimum element. Number one, you need to find out the minimum element, and you need to do the swapping, right? So, for finding the minimum element, we need to initialize an array. We need to initialize an array. So, you can see that private static void selection sort. I'm initializing one array over here, and here what you can do, you can take some functions like find pause. Find pause is a another function. So by using this function, it is possible to find out the minimum element of the given array. Okay, so already I was discussing this part in the last class. Okay, so how to find out the smallest element in the array. How to find out the smallest element in the array. So you can see that private static find pause int x int n, then for I equal to 0 I less than n I plus plus. If x of I less than x of k, then x equals to I, then return k. So in this way, so you need to find out the smallest element. You need to find out the smallest element. Okay, so after finding the smallest element, what I would be doing, I would be actually calling the selection sort function. I would be calling the selection sort functions. So now my objective is how to call the selection sort function. So selection sort function is one kind of functions, like it will be actually doing the rest of the things, like there are many parts are there, like we need to find out the minimum element, then we need to do the swapping, then we need to call the selection sort recursively. Okay, so after performing this recursive function, so what you can do, this is the things you need to find out this. So find the minimum pause big O n and swap big O1. Therefore, the recurrence relations for the running time of the selection sort is t of 0 a, and t of n is tn minus 1 plus n plus c, where if n greater than 0. Okay, so these are the things you need to understand. T of 0 equals to a, and t of n equal to tn minus 1 plus n plus c. So actually I was discussing this part in the last class. I was discussing this. So now you can see that we need to substitute n minus 1 to n to n minus 1. So what I can do, n minus 2 plus n minus 1 plus c. In this way, in place of n I would be writing n minus 1. Okay, so n minus 2, then n minus 1 plus c, then n plus c. So in this way, what I would be doing, t of n minus 2 plus n minus 1 plus n plus 2c. Then n minus 2, then I need to give another functions here, like n minus 1. In place of n minus 1, I would be writing n minus 1 n. In place of n, I will be writing n minus 1, so I will get n minus 3. then n minus 2, then plus c, then n minus 1 plus n plus 2c, t of n minus 3 plus n minus 2 plus n minus 1 plus n plus 3c. So in this way, the things are happening. So you can see, if you are not understanding, please let me know. So in this way, we need to find out the time complexity of the recursive algorithm. Okay. So if I am putting n equal to suppose I am putting n minus 4, if I am writing, so I am putting n minus k, then n minus k plus 1, n minus k plus 2 plus n plus kc. In this way we are doing. So now what I would be doing for the best case, you know that n minus k equal to 0. For the best case, you should know that n minus k equal to 0, that is k equal to n. So then we can do this kind of applications like t of n equal to t0 plus 1 plus 2 plus n plus nc. So now t of 0 equals to a. You can I think it is known to you, t of 0 equals to a. Then I equal to 1 to n I plus cn. So now here you can see that I can write, this is the actually n into n plus 1 by 2. It is known to everyone that if I am putting 1 plus 2 plus 3, so you will get n into n plus 1 by 2, like n square by 2 plus n by 2 plus c of n. Okay, so n square by 2 plus c plus half of n plus a, if I am putting the constant a. So what would be the maximum polynomial? That is n square. The maximum polynomial would be n square, big O n square. So recursive selection sort. The maximum, actually maximum polynomial of recursive selection sort is big O n square. So in this way, you need to understand the topic. Okay, in this way you need to understand the topic. So you can see what I am doing. Again, I am showing something to you: analysis of recursive selection sort. Okay, so in this way, so if it is actually in Java program, so you can write C++ code for these recursive functions. Okay, you can, it is actually Java program, you can write recursive code for C++ function also. So in that C++ function, you need to mention minimum element. You need to find out minimum element. You need to find out you have to do swapping also. You need to do swapping also. So this is the things you need to understand this. Okay, so actually now what you can do, if I am telling try to find out the time complexity of bubble sort recursively, is it possible to do? Is it possible to do if I am telling you try to find out the time complexity of bubble sort recursively? Is it possible to do or not? Kindly tell me how to find out the time complexity of bubble sort. Anyone? Recursive functions. Do you know what would be the recursive function of bubble sort? Anyone? Hello everyone. Can you please let me know? Bubble sort, I think it is known to everyone, right? So now what I'm telling you, try to find out the recursive function of bubble sort. Anyone? Am I audible to you? Are you listening to me? What I'm telling? Yes. So kindly tell me what would be the recursive function of bubble sort? Do you have any idea? So can you write the recurrence relations of bubble sort? Recurrence relations of bubble sort. What would be the recurrence relations of bubble sort? Can you please tell me? n into n minus 1 by 2. So if I am applying substitution method, okay, if I am applying substitution method, then what I would be getting in case of bubble sort? Any idea, anything else? Anmol, anything else? Can you please tell me how to find out time complexity of bubble sort? Hello everyone. Are you listening to me? Anmol? Are you there? Chirag? Yes, yes. Actually, I am trying to mention that how to calculate time complexity of bubble sort. How to calculate time complexity of bubble sort. So if I am trying to find out the time complexity of the bubble sort, then I would be doing the same approach. Na? You can see. So I need to write the recursive code. So I think actually, have you done the recursive bubble sort algorithm? Do you know? Recursive bubble sort algorithm, do you know? No, sir. Yes, sir. So, Mohammad Bilal, can you please tell me what would be the recursive bubble sort algorithm? Recursive way. So, we know bubble sort. So, we need to do it recursively. Okay, we know bubble sort, but we need to do it recursively. So, how I can do it? How I can do it? Yes, with the help of recursion. So, do you know what would be the recursive code of bubble sort? What changes to be made in this here? What changes to be made? You can see recursion is here. Private static void swap recursion is here. Okay, so you can see that int min pose int n temp. Okay, min pose temp recursion is here also. So now this is the fixed function. This is the fixed function. So now what I will be doing, so what changes to be made here in this code, what changes to be made. So this is the fixed function, bubble sort x dot length minus 1. So now, so already I have mentioned 2 points. This last function and this first function is fixed. So you need to make some changes inside this. So what changes to be done? Recalling the function within the function until the size is 0. Yes, that is the good idea, but how to do the recursive functions? How to call the recursive functions? Here in this code, you can see this is the recursive code, na? So in this way, you need to think what would the recursive code of bubble sort? The private static void selection sort is there. Private static int find minimum pose is there. Okay, selection sort is there, minimum position is there. So now it is, you can see private static swap, another function is there, and this is another function. So in between I need to do some changes. I need to do some changes. What changes to be done? So I need to take one functions that will be actually calling the loops. Okay, so actually you know that in the recursion we are not able to use loop. Okay, if I am writing some function recursively, then we are not able to use a loop. Understood? So here what I would be doing, can you please tell me here what I would be doing? Anything else? So it is your homework. Okay, everyone please try to find out the recursive function of bubble sort. Okay, everyone, try to find out the recursive functions of bubble sort, and then you need to find out the recurrence relations. Then you need to calculate the time complexity of bubble sort algorithm. So is it clear or not? Let me know. So I'm hoping that if you're understanding, then obviously you can do it. You can take your time, then try to write the recursive code of bubble sort. Try to write the recursive code of bubble sort. Then, then what you have to do? If I am writing the recursive code of bubble sort, yes, n minus k into 1. What you can do, just try to write the recursive code of bubble sort. Okay. Then you need to draw the just what should I say, the recurrence relations. You need to create the recurrence relations. Then after creating recurrence relations, you need to find out time complexity. Okay, you need to find out time complexity. In this way you need to think. Okay, everyone, understood what I'm telling to you? So now you can see there are many examples are there. Many examples are there. So you can use recursions in this. What is recurrence relations? T of n equals to a 2tn by 2 plus bn plus c. If n equal to 1, then a. If n greater than 1, then this. If n equal to 1, then it will be returning a. If n greater than 1, then it will be returning 2. 2t n by 2. Okay, there must be some constant value. There some must be some constant value. Without constant, I could not write the recurrence relations. Okay, so that's why I'm telling you. This is very very important. So up to this, I think clear everyone. What I am discussing till now, I have actually taken only 3-4 classes till now. So up to this, is it clear or not? Please let me know. Okay, so now today I will giving you some idea of master theorem also. So this is the master theorem. You can see that this is another procedure to find out the time complexity of recursive algorithm. Okay, this is another procedure. So there is some formula of this master theorem. Okay, what is the formula? The master method provides an estimate of growth rate of the solution for recurrence of the form of Tn equals to d a of t n by b plus f of n if n equals to 1 and if n greater than 1. So these are the two actually two conditions you need to put. These are the two conditions you need to put. So Tn equals to d and a of t n by b plus fn. So you need to put these conditions. N equals to 1 and n greater than 1. Where a greater than equal to 1 and b greater than 1. And overhead function is f of n greater than 0. Okay, so you need to actually, this is the master theorem formula. So if you are telling sir how it comes, it is actually formula like a plus b whole square equals to a square plus 2ab plus b square. It is known to everyone. Okay, so like this is the formula. This is already we are actually taking this formula to calculate the time complexity of recursive functions. Okay, like t of n equals to d, then d means if I am putting t of n equals to d, then if n equal to 1. At e of t n by b plus fn, then n greater than 1. Okay, so these are the things you need to understand. Where a greater than 1, then b greater than 1, then override function af greater than 0. Okay, so now you can see t of n number of sub problems. Then a is what? A is a constant T of n by B sub problem size. Then price of dividing the problem and combining the solution. These are the things. If you are telling, so what about this? T of n is a function. You know that it is a function, number of steps. That's why it is written as T of n. What is a? Number of sub problems. A is number of sub problems. T into n by B means sub problem size. N by B means sub problem size. Okay, and Fn means price for dividing the problem and combining the solution. Price for dividing the problem and combining the solution. So these are the functions. Okay, so now you can see divide and conquer algorithm, like what we are doing: divide the problem into number of sub problem, conquer means the sub problems, combine means the sub problem solution to get the solution to the original problem. Okay, divide and conquer. So we actually already I have discussed some strategy of some techniques of designing analysis of algorithm, like divide and conquer. Okay, so we can apply divide and conquer process for merge sort. Okay, for quick sort we can apply this. So if we are applying actually divide and conquer, then what I would be doing, actually this master theorem is actually applicable for divide and conquer. Okay, so suppose if we are doing merge sort, if we are doing quick sort, if we are doing heap sort, then we need to apply the concept of divide and conquer. Okay, we need to apply the concept of divide and conquer. So if I am applying the concept of divide and conquer, then what I will get? So this is the things: T of n equals to A of t n by b plus f of n. So T of n is what? Number of sub problems. A is size, problem size. N by b means size, sub problem size. Price of dividing the problem and combining the solutions. This is Fn. These are the things you need to understand that. You need to understand that. Okay, divide means the n elements sequence to be sorted into n by 2 element sequence. Conquer means the sub problems recursively using merge sort. Combine means the resulting two sorted n by 2 element sequences by merging. So these are the things we are doing. Okay, so before going to apply master theorem, we need to know upon which kind of algorithm we would be applying this concept. Okay, so this is the master theorem. You need to understand this formula. So A is number of sub problem. So if we are applying this concept, then you will be getting in case of merge sort, we are having many number of sub problems. Then T of n by b means sub problem size. Then function price of dividing the problem and combining the solution. That is the uh, price for dividing the problem and combining the solutions. That is the functions. Okay, so sub problem size, number of sub problem, and this is the T of n. In this way you need to understand. Okay, so you can see that Tn is interpreted as number of steps needed to execute an algorithm for input size n. This recurrence corresponds to a divide and conquer algorithm in which problem of size n is divided into a sub problems of size n by b, where a and b are positive constants. You need to understand this. T of n equals to a into T of n by b plus fn. Okay, so now you can see divide and n element sequence to be sorted into 2 n by 2 element sequence, then conquer recursively. So you actually sub problem size means you can see that number of sub problems. So we can denote the number of sub problems in terms of a. We can actually sub problem size. So we need to find out what would be the size of sub problem. That would be n by b, and fn is a function. How many times we are doing the operations in this way. So you can see. So this is the actually simplified recurrence relations. So you can see that. So if I am considering some recurrence relations over here, t of 1 equals to 1 and t of n equals to a t n by b plus k n to the power c plus h. Suppose I am taking this. Suppose I am considering this. So for this constant, a greater than 1, b greater than 1, c greater than equal to 0, k greater than equal to 1, h greater than equal to 0. Suppose I am taking this value. So now T of n, so actually there is some formula. You need to understand this formula. The T of n belongs to T of n belongs to a to the power. Actually, it is very difficult to understand. You just try to actually, I would be telling you clearly because this expression is not written properly. So actually, these are the conditions I will be discussing once again for you. But right now, you just assume these are the conditions. These conditions to be satisfied. Okay, if I am using this master theorem, then this condition has to be satisfied. Otherwise, it will not get executed. This is the things you need to understand that. Okay, suppose if I am taking this example, t of n equals to 1 for n equal to 1 and 3tn by 4 plus root n for n greater than 1. So now if I am applying master theorem here, so you can see if I am considering this master theorem a into t n by b plus fn, if I am applying this master theorem, then I will get this a equal to 3, b equal to 4, c equal to half, then a greater than b to the power c, case 1. So hence Tn is b go n to the power log 4 to the base 3. Okay, try to understand what I am saying. Suppose if this is the recurrence relations and this is my master theorem. This is the recurrence relations and this is my master theorem. You can see that T of n equals to d a of Tn by b plus Fn, and this is the actually recurrence relations. Now you can see that a means what? If I am considering a means what? A is 3. N by b, n by b means b is 4. You can see that b is 4. C is half. So if I am putting n to the power half, so you can say n to the power half. Okay, fn n to the power half. So that is why c is written. Now you can say that a greater than b to the power c. So if it is coming in this way, you can say a greater than b to the power c. Why? Because in case 1, in the previous slide, this is the case 1, a greater than b to the power c. Okay, a equal to b to the power c and a less than b to the power c. So here we need to find out. You can see that a greater than b to the power c. Okay, so if I am doing this a, so you can calculate this. A is 3 and b is 4 and c is half. So b would be 2. So 3 greater than 2, isn't it? 3 greater than 2. So if we are getting this situation, then you can write the complexity would be in log 4 to the base 3. So this is the a. Okay, and b value is 4. So you can write this. Understood or not? Please try to understand this. Let me know. Is it clear? Hello everyone. If it is not clear, please let me know. Mohammad Bilal, is it clear? So you can see that again I'm just discussing. So this is the master theorem. T of n equals to a into t n by b plus fn. Try to understand it. T of n equal to a into t into n by b plus fn. Okay, and this is the simplified. T of n equals to 1 3 t n by 4 plus root n. This is the another example. So if I am actually comparing this, so you will get this value. Na? So if you have any confusion, please let me know how it comes, how these values are calculated. A is 3, B is 4, C is half, A greater than B to the power C. How is that calculated? Please let me know. Is it clear or not? Is it clear, everyone? Recurrence relations. Akash Pandey, sir, please explain again the recurrence relation. Which recurrence relation, Akash Pandey? So I am giving you mic permissions also. Now I am giving mic permission to you. So can you please tell me which recurrence relation?
Good morning, sir. Am I audible?
Yes, you're audible.
Yeah, sir. This one, sir. This value, where this value came from, sir? This not.
This value.
Yes, sir. Yes.
Actually, it is an example. It is an example.
No, sir.
Okay.
How you are implementing this example in master theorem, sir? Please
Okay, okay,
explain
okay,
one more, sir.
okay, 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 okay. So T of n equals to 1, 3 of t n by 4. So now I need to check how many sub problems are there. So you can see that what actually what I have been explaining at the beginning. So this is the things. This is the master theorem. T of n equals to a into t into n by b plus fn. T of n equals to a into t n by b plus fn. So this is the master theorem. This is the master theorem. So now what I would be doing, so I am comparing with that master theorem with this value. Okay, so you can see that D, how much D? D is what? Here D is 1. D is 1. So 3T. So 3T means you can see A T N by B. A T N by B. So A T N by means A means what? 3. N by B means, so B is 4. You can see that B is 4. And plus n to the power half. N to the power half means C equal to half. Understood or not? So I am just comparing this equation with this equation. I will get these values. Is it clear or not? Not
Yes,
yet.
sir. Not clear, sir. Thank you.
Okay, now you can see that it is written a greater than b to the power c. So why? From where I am writing this a greater than b to the power c, a equal to b to the power c, a less than b to the power c. These are the conditions. A greater than b to the power c, a equal to b to the power c, a less than b to the power c. These are the conditions, right? Okay, so now these conditions I need to check which condition is satisfying here. So why I am writing a greater than b to the power c? Because I will be checking all the conditions one by one. Okay, so you can see that all the conditions I am taking one by one. So you can see a greater than b to the power c means what? A greater than b to the power c means this. A greater than b to the power c means a is 3, b to the power c means b is 4, c means half. So if I am calculating, obviously I will be getting a greater than b to the power c. So actually now I need to calculate all the things, but this condition is satisfying. These conditions are not satisfying. Okay, so if this condition is satisfying, then we can write this in log ba. So the complexity would be in log ba, n to the power log b to the base a. So a is 3 and b is 4. So you can see that from here I am getting, if this condition is satisfying, then the formula I will take this. Actually it is not written correctly, very difficult to understand. That's why I am telling you this is the correct form. Okay, if this condition is satisfying, then I can write this. If the next condition is satisfying, if it is satisfying, then you can write n to the power c log n. Okay, in this way. If this condition is satisfying, n to the power c, then you can write a less than b to the power c. If n a less than b to the power c, then you can write n to the power c. Okay, so in this way you can calculate the time complexity with the help of master theorem. Understood? So if I am actually, now you can see example 2, find the big O H running time complexity of master theorem. So T of n equals to, now another example they have given, T of 1 equals to this 2t n by 2 n. So if I am applying this, so you can see this condition is satisfying, right? So a is 2, b is 2, c to the power 1 means c means 1, means a equal to b. It is satisfying, so you can write big O n log n. If I am taking these conditions, then I can write big O n cube. So in this way, by using master theorem, you can calculate the time complexity of a given recurrence relations. Okay, is it clear everyone? Okay, I will be discussing once again. I will be giving more example. Is it clear everyone or not? Hello. Hello everyone. Is it clear? Okay, thank you. Thank you. Thank you everyone. Thank you. So if it is not clear, please let me know. Okay. Mohammad Bilal, Chirag Lala, please let me know.